Solving equations. There's a couple of definitions here that you just wrote down. One of them is the addition property of equality, which is if you add the same number to each side of an equation, it stays the same. It's going to remain to be equal. Okay? It's going to remain to be equal. So that's just saying that when you have do you guys agree that 5 is equal to 5?
Yeah.
Okay? I need you to write that down. 5 is equal to 5. So do you agree that if I were to add 10 to both sides, that equal sign stays true?
Yeah.
So I'm going to do that. I have 5. I'm going to add 10 to this side. I'm going to add 10 to this side. That's still going to be what now?
15.
Okay, 15. And is 15 equal to 15?
Yeah.
Yes, it is. That's what that property is saying. Then we have the subtraction property of subtraction property. If you subtract the same number from each side of an equation, it stays equal. Same thing as what we did with addition just now. Now here's an example, and I'm sure that some of you probably shrieked inside when you saw an addition mat. Okay? And not because of a positive shriek, like where you see one of your favorite artists in person. I don't know. That's it. I don't know why that introduced all the talking. Hey, you 7, stop.
6.
Examples. This is what this is representing. We have a cup, and we don't know how many, we'll call them ping pong balls. We don't know how many ping pong balls are in the cup. So what do we do mathematically when we don't know what something is? Yes. You assign a variable. That's what x is. Okay? That's what x is. Now, you're going to hear me say this a lot over the next 3 quarters. Whenever we're solving for a variable, just imagine that a variable wants to be alone. It is asocial. It just wants to chill by itself. There's nothing wrong with it. It just wants to be alone. So whenever anything's happening to it, stuff is being added to it, stuff is being subtracted from it, it's like, leave me alone, bro. I'm just hanging out. Okay? And can you organize that mountain of paper some other time? So I need you to just close that and put it away. I also have 5 integers here. These ping pong balls are 5, and that's what it is here. So we have an unknown plus 5. We can see those 5. Okay? We can see those 5. And that is going to equal a total of 8. So I know that inside that cup and those 5 that I can see have a total of 8 ping pong balls. So what's happening in this next step here is we are getting rid of the ones that we can see. I know that these 5 are right here. So I'm taking those 5 away and those 5 away because I'm wondering how many are in that cup. Okay, I can see that there are 5 in front of me, and I can see that there's a total of 8, so I can remove those 5. And that leaves 3. There are 3 ping pong balls. Where are those ping pong balls? In the cup. Okay? It's in the cup. So there it is, visually represented. After they get taken out, now we just have x equals 3. That vertical line down the middle, that's like an equal sign, okay? Can I get that for me? There, you don't need that. Thanks. I see what you're saying. That was an addition mat. This is something very similar to that, but this example is showing you what's happening. We won't even do this anymore. You won't be expected to do this on your homework either. Now, here's what's happening outside of the mats. We have x plus 5 is equal to 8. I have given the highlighters that same representation. Now, remember what I told you about x? Does it like hanging out with people?
Yeah.
No, it wants to just be alone, and that's okay sometimes. It's okay to be asocial sometimes. Somebody just want to chill by yourself. So what's happening is, what's happening to x? Okay? What's happening to x when we first look at this problem? Okay, let's raise our hand. Yes. Yes, 5 is being added to it. 5 is being added to it. So x is chilling and 5 people come over and it's just like, guys, come on. I like you guys, but I'd rather hang out by myself. So those 5 people would be asked to leave, right? So it's going to be going the opposite direction. What's the opposite of plus 5? Minus 5. And look what's happening here. Minus 5. Don't want that to be blue. So they're subtracting. Stop. They're subtracting 5 after 5 was added. Subtracting 5 after 5 was added. And in order to keep this equal sign true, the subtraction property of equality, you have to do that for both sides of the equation. The equal sign, both sides need to have it. So if you're going to take away 5 from this side of it, you need to take 5 away from that side of it. So 5 from x plus 5 is just x left over. 8 minus 5 is 3. Okay? Let's do some examples, but first I want you to write this down. Inverse operation. Inverse operations. Addition undoes subtraction. Yep. Present progressive of undo. Vice versa means also sub addition. Just stop. Like put that in a pocket or something. Oh, that's the second time I've heard you making that noise. Addition undoes subtraction, and vice versa. That's without saying and subtraction undoes addition. They're both opposites of each other. If something's being added and I don't want it to be added anymore, I would subtract what's happening. Okay? If your backpack is too full, you had it just right, then you put a whole bunch of stuff back in it, you'd want to take some stuff out of it so it's just right again. It would be the same amount. So the inverse operation. All right. Does anybody know how that? All right. Here we go. I have 71 is equal to h plus 93. You have to first ask yourself, what is happening to the variable? Remember, wants to be alone, Mr. Webb. Basketball?
What? No, I know what the answer is.
Well, can you answer the question I just asked? What? Okay, when the hand goes up, still keep your ears open, people. It's not a valve. Okay? What is happening? Actually, answer this. What is happening to the variable?
It is like pushing everything out.
Yes, it is. Okay, that's a good way to put it. So it wants to push everything out, but right now there's 94 or 93 of something that's hanging out with it, right?
Yeah.
So it's safe to say that what's happening to the variable? 93 is being added to the variable. How do you make that not happen? You take away the 93. I need that equal sign to hold true, so I have to do it to the other side as well. Now we go back to yesterday's homework and we follow our integer rules. Negative 22 equals h. If you do not have the variable in there at the end of it, it's not going to be full credit. And if you're wondering why I did 93 minus 71, that was in yesterday's notes. It's a subtraction property for integers. Excuse me. Yes, sir. I can't imagine you ruining a lesson. Now we have this guy, 12 plus p. Okay? What's happening to the variable? It is being added to 12. But this variable doesn't like to be added to 12, so it's going to take 12 away from it. With my integer properties, I know that I can add a negative in there instead of subtracting. The answer is negative 57. Negative 57. That's yesterday. Okay. There's a reason we did integers before this, because the new stuff is the easy stuff. Now this one's a little bit different. I want you to try this one and only go that far. Stop tapping. I want you to try this one. And make sure you're writing down whatever I write down on the board. So when you go back and look at this when you're doing the homework, you'll be able to see what's going on. Okay. How familiar are you with integers? Cool, perfect. I'm going to give you the notes from yesterday, and that'll help you out a lot. Here's that for you. So if you have this, you did it right. So here's what just happened. I know that a lot of people earlier in the day got that one wrong. Keep in mind that you're trying to undo what's happening to the variable. What's happening to the variable there is 39 is being taken away from it. You want to undo that by adding 39 to get it by itself. Then negative 4 plus 39 is 35. Yes, sir?
So like when we're doing our work tonight and we're doing like, say it's this one, is 39 over 4, is it plus or minus? Because how do you know what minus? It's just
Okay, so do a short review over what we had already earlier this year, what you had last year in 6th grade, and what yesterday's whole lesson was about, that you even told me how easy it was. Negative 4 plus 39. Negative, and often parentheses are for negatives. I got to email your pops back because he had a really good question about negatives with parentheses. It's a really good question. In their notes yesterday, it was mixed between the two where it should have been in parentheses. That parentheses is often what they do with negative integers. But I have 39. Whenever I have different signs, as it says in the notes you have, 2 inches from you right now, you take the difference between the two, and you keep the sign of the bigger one. Yeah, I'm going to keep that there. Wow. Next one. This one here is not simplified. We need to simplify it first. Simplify it first. Okay. So I'm going to simplify this. Remember, this is the negative. Says it's subtraction, so it's keep, change. Now we can see that y is being added to 34. To undo that, I'm going to subtract 34 from both sides. 69 equals y. And you could also say y equals 69 because it's the same exact thing. No. Nope. The ones digit would have to be a 9 because look at the difference. Any questions on that one? Next, we are going to rewrite this guy because we have subtraction, so we're going to keep, change. That's the action. That's the action of multiplying fractions. That's keep, change, flip. And since 25 is being added to x, we need to subtract 25. Okay, for those of you that are making noise right now, there are others that are going through and they're processing this information. Please let them do that without hearing your voice mumble in the backs of their heads. Yes? The x in algebra does have a little tail on it, so you don't confuse it with multiplication. I would like you to Smith number 8. I would like you right now. I would like you right now to do 6 through 11. Please do 6 through 11. I'm going to walk around a little bit to make sure you guys are getting off to the right track. Then I'm going to do the first step on the board in just a little bit to make sure that you're not going to be doing them all the wrong way. But I'll do the first step with you. Remember to think what is happening to the variable. What is happening to the variable? Undo what's happening to the variable. I want you to do the same layout that we've done on all the other questions, please. So if you're unfamiliar with the layout or what it should have been, or if you weren't copying it down correct, it should be looking like that with the numbers directly below them. You'll have a little bit of room on the homework tonight, but yes. What's happening to G? Nothing. Looks like something's happened to it. It's not by itself yet. What's happening to M? See how you don't have the sign there? I need a plus there. For some reason, this was in Ethan's binder. if you're stuck, I've done the first step on all of those so far. Did they come off okay? Did it come off okay?
Yeah.
Good, good. So that's what you should have for 6 through 11. Number 6, G is having 5 taken away from it. So the opposite of negative 5 would be to add 5. Now for these 4 we're going to do together. We're actually going to do the integer part of it as well because both times I've taught this today before now had questions about that. So here's number 12. We have 183 being added to x. So I have to make 183 go away from x. So subtract 183, subtract 183. And my integer rules say that whenever I have the same sign, and I'm subtracting, oops. 1 second. Yeah, subtracting 183. I'm going to do the keep, change, change. Keep, change, change. 183. Ooh. And when I do that, I just add those two together and keep the sign. And that's 417. Keep the sign, 417. Ew, 417. Good. Okay, I repeat, because of the integer rules that you learned last year, during the 3rd week of school this year, and also yesterday, whenever you have addition of 2 of the same signs, you add the digits together and keep that sign. Next one. First thing we're going to do is simplify. We have 2 negatives, and we know that double negative. Shh. If you have a question, ask me. I'm going to first change that because double negative is a positive. $112 is being added to m, so I must take that away. Oops, 7. Becomes negative 703m. because I'm just undoing what's happening to the variable. Yep. Only in subtraction do you keep change. Now this one here goes back to last week. We have, stop tapping. We have some like terms here. First, we must combine like terms. There's somebody during fifth period who wanted to undo the plus -2, then they wanted to undo the 5. That's fine. You'll still get the same answer. You're just going to have 2 more steps than I will. So first step, I'm going to combine like terms. I have 2 integers. 5 minus 2 is 3. I'm going to have that line up. Because I did 5 minus 2, or 5 plus -2 is 3. Then I'm going to subtract 3 from this side, subtract 3 from this side. That just leaves f equals 3. Yes, sir.
Shouldn't the 5 and 2 be in brackets? Yeah.
5 and 2 be in brackets? No. Nope. By order of operations, we have parentheses, but there's no multiplication going on there.
Oh.
And what we learned from combining like terms and distributive property, we can't do anything with that 5 plus f. We don't know what f is, so we can't add to it. Last but not least, we do have some brackets in a very similar situation, but that's just telling us what we need to do first. First thing we have to do is we have to take care of this. So we have n plus 2 plus -3. Parentheses around that, so we know that it's a -3, not subtracting by 3. Okay? The parentheses are there saying, hey, this isn't subtraction, this is a negative number. Now I'm going to continue to simplify. N plus 2 minus 3 is going to be n minus 3. What? No. N minus 1. Plus -1. Which is the same thing as n minus 1. Okay. Now I'm going to undo what's being done. It's being an n plus -1, so we need to remove a -1. We're going to remove a -1, so it's subtracting a -1. And we have to do the same thing over here. Remove a -1. And what do we know about a double negative when you subtract a negative? Positive. So it's going to be adding 1 actually to this. 17 is n. Thank you for calling Scott Smith. Scott speaking. How can I help you? Yes. Do you know if you're getting picked up early, Caleb? Does he need to pick something up, or is he leaving, or? Okay, just making sure. Thanks. Bye. No, you're coming back. You're down in the office. Thanks. Yes. So we got 17 is equal to n. But wait, there's more. We can find out if we're doing the right question by doing something that we've been doing all quarter. Learning. No. Check yourself. Yes, we want no wreckage. So we can check yourself by doing something that we've been doing all quarter. Not all quarter, actually, all year, because it's second quarter. You substitute or evaluate for the variable you found. Let's try it with the front side on a couple of them. So we have 3. We're going to check it. I'm going to take, I found that n is 35. So I'm going to insert I'm going to evaluate where m is equal to 35. So I'm going to put it into this one. M minus 39 equals negative 4. So I'm going to substitute that green in there. 35. Come on. Minus 39 is equal to 4. 35 minus 39 is negative 4. And do you agree that negative 4 is equal to negative 4? Yes. That means we did it right. And I can put a check mark there. Try to know. Scott Smith. Hi. Yes. Yes. Hi. All right. So that's the way we checked ourselves. If we did it wrong, let's say that over here we did our arithmetic wrong, and we did we got 36 over here. You don't have to write this down. Let's say we got 30, no, we'll go 32. Okay, let's say that's the answer that we got. When we would insert 32 for this, 32 minus 39 is negative 7. Does negative 7 equal negative 4? No. So that would be wrong. That would be wrong. Okay? Let me get that out of there. Any questions about that? No? Good.